Hello everyone, while we're getting set up, I'd like to welcome you to SyDjango 6. This is our 6th event, hence the number, but our first one for the year. We're hoping that with the growing community and the growing sponsors that we have, that we're hoping to host these a bit more often and hopefully also spread a little bit beyond just Django and cover a bit more of the Python ecosystem as we go. So stay tuned and please let us know what you think of the talks tonight, what you think of the organizing of the event, because we're very open to feedback and how to progress. And please get involved. This can't happen without volunteers. I was once one of you, as were most of the people here. Before we start, I'd just want to give the possibility for our sponsor, our new sponsor, Opens, that I used to work with until very recently, till the very end of last year, has kindly offered to co-sponsor this event together with Cover Genius and a few other sponsors, but this particular event is sponsored by Open, and I'd like to welcome Lisa Zhu, who's the GM of Engineering, to speak.
Thanks, Rui. Thanks, everyone. Welcome to the event. I miss working with people like Rui, excellent talent out there. So if you ever need someone who's going to solve your problems, come in and come out so that he can retain his retirement, hit him up. Here you go, free advertising for you. Open, a little bit about us. We have nothing to do with OpenAI, in case you're wondering. Don't know any of your AI questions, but we are working in AI and we are looking forward to take advantage of it. We are very much in the insurance space, looking to disrupt it and really bringing the next level of product and customer experience that we can actually create a delight and engagement for customers. Because insurance over the years, I don't know if you use insurance, but for me, long forms, lots of questions, sometimes it's just you stay on the phone to get anything done. And we're very much about disrupting it through the digital section on how do we do that seamlessly, easily, and just when you need it. And we are very much in the car and home space. We have a mobile insurance offering in the UK, and we also have a travel insurance. So if you're looking out for us, you can search for our direct-to-consumer brand called Huddle. And a few of our team are here looking at me because they know who I am. But we're also hiring for senior engineers and an engineering manager at the moment in the Python space. So if you're interested, come and chat to us. Ready?
Cool.
Without further ado, I'd like to introduce Alex, who's going to give our first talk of the evening.
Thanks, Rui. Is this working?
Yeah.
Yep.
You'll need this. This works for the room. That
works for the I need both. Okay. Hi everyone. My name's Alex. This talk is titled "Distributed Systems Problem." I think there's a bit of a different title on the Meetup invite, but we'll get to that in a second. So yes, this is a talk about balancing high load in a distributed system. It's about minimizing delays, side effects, not having downtime. It's about observability, and it's a lot of painful points I learnt along this way. Oh yes. So yeah, this is what we'll talk about today. So the problem, some context, the solution we had, hurdles, what we learned, and what we'll do next time. So. Who am I? My name's Alex. I've been at CG for 4 years. I'm currently a manager on a customer-focused team. I do work on the back end with Python. The stack is Python, K8, Celery, etc. And yeah, I've been at CG for 4 years. Been through a couple of teams. Moving on. So yes, the problem. Our product. Our platform Xcover updated our privacy policy, and for compliance, there's a missing C there. We had to email existing customers under some condition. I won't get into that, it's kind of business logic-y, but we had to notify our customers about this update. And what the update was about was, we started to use AI to process some of their data and to give them a more contextual answer via a chatbot. So yeah, points to consider in solving this problem. There was about 15 million customers we had to email. It's the last 2 weeks of the year, so it's a terrible time to do such a huge solution for such an annoying problem. Of course, we don't want to have an impact on functionality. We don't want downtime, and we want to do it simply and easily. So without people with all hands on deck, because it's the end of the year, people are on holidays. And no one wants to be working too hard over Christmas and such. So just some context. For all who are here from CG, I've renamed some services, so it's a bit more generic and easy to understand, but this is kind of what this little, the context for this problem looked like. In our Xcover system, we had a customer service with a Postgres DB and Redis, and we had an email service, and we talked via HTTPS on this endpoint there, that API v1 mail, and that talked to SendGrid. Interesting to note here, with our plan with SendGrid, there was no rate limiting on their API, so keep that in mind, considering we had 15 million customers to send. So yeah, no rate limiting. And yeah, the technology, Postgres, Celery, Redis, and Kubernetes. Probably won't hear me talk about Django too much today. Apologies for anyone who was excited for that. So our solution, so we committed 15 files using Git LFS. So each of these files had 1 million rows. And this is kind of this interesting diagram of what it kind of looks like in functional sense. That's me in my web pod, and I'm running a Django management command. It creates a Celery task, and then on a periodic basis, a child task is created, and it processes a batch out of this file. So in doing that, we did this on purpose. We wanted it to not smash the email service, because everything has to remain up. We don't want big delays that will affect other Xcore functionality. And yeah, we did the timing and the spacing like that intentionally. So obviously with these parameters, we can do some back in the envelope calculations. So 15 million emails divided by, if we do a batch with 10,000 and we space it by 20, it's about 20 days to run 15 million of this. And that's, running it, as soon as one file is done, we run another one by the management command. Obviously that's, a pain in the butt. But given the time of the year, the limited resources, and, products urgency to do this, it was kind of a simpler way. Playing around with these parameters, if we increase the batch to 20,000 and lower the frequency to 10, we can get 5 days. So just something to keep in mind. You'll see later, I'll reference how we did end up tuning the system to complete more of these quicker. Okay, so yeah, we're getting into code. So I've got 3 slides of code. We're just going to quickly go through them. I don't want to spend too much time on it, but this is what the management command looks like. We're using DJ Click. It's really nice, and it basically just creates that parent Celery task we saw. This is where we're creating the children. So we've got this constant task frequency. We've got a bunch of types there. See that batch, to dict, customer ID language, we're using ETA. So that's an important point. So on the apply async line, you can see in that loop, we're going through the CSV file, we're creating a batch, then we're putting it into this Celery task using apply async, and we've got ETA. So I'm going to get back to that in a bit, but something to keep in mind. And then in the task, we're basically iterating for each customer, and we're sending the email. Now note, we've got on our customer object, we've got a column called policy update 2024 email sent. We write to that when it's successfully be done, in order to keep it somewhat idempotent in case, I don't know, something happened and we had to redo it. And yeah, we just wanted to keep it idempotency so customers don't get emails several times. It's not the prettiest code. Anyway, a big part of the solution is obviously having observability. The whole time we were running it, we had Datadog dashboard set up. I would love to show diagrams of the dashboard, but I couldn't work out how to use flex logs on my dashboard. So there's no photos of the dashboard. Yeah, RDS obviously, because we'll talk about the database issues we have soon. But yeah, performance insights are great. We use Grafana to track the celery task creation, things like that. Just keep in mind, yeah, if shit hits the fan, we need a way to stop it. Say this email service just we cause a DDoS attack on the email service. We need a way to stop this. And for some failed requests, for whatever reason, we need to see why they failed, and we need to try again in the future. We need to have some ways of scraping the failed customer IDs and then rerunning it. So these are just things built into the solution. And yeah, just some on the infra side, we increased max replicas for the web and worker pods on the emails. On the email service from 10 to 35. So we're confident that the app could warm up quickly. It's a pretty lightweight API. Our min replicas were still quite low, but because of the quick warm up, we were confident just having a higher max replicas. We didn't need to set the higher min replicas in order to just be a bit resourceful. And yeah. All right, where are we? So yeah, when we ran it, we we started with small batches, obviously just testing it out, making sure our observability was fine and we could see everything we wanted to see. We slowly increased the size and ideally decreased the frequency period just to get it all out and so we could enjoy Christmas. So yes, so the first small batches worked, and then we started doing large batches. I think the first large batch I would have done was like 500,000, which with this 10K batch size, that's 500 tasks. No, so that's 50 tasks. So yeah, we started getting a CPU bottleneck on the email service database. So you can see Aldous, the manager of this team, 145 replies. It wasn't pretty. So this got pretty interesting. Our DevOps, Danielle from DevOps, who is obviously very skilled at databases, just knew his stuff, ran in explain, analyze, and you could see that the index is located quickly, but the update is taking time. So we can see that we're updating a row frequently, and he suggested to increase the shared buffer size. So this is the first DevOps solution, part one. So there's a lot going on here. I'll just quickly go over it. So shared buffers. So shared buffers is cache in Postgres. Basically, you do a select, you'll check the cache. If it's not there, it'll go to disk, put it in the cache, as you'd imagine. So increasing the shared buffers meant that there's more memory to cache, which is typical to do in a high writes sort of period of traffic. So yeah, auto vacuums are mentioned there. So when a row is updated or deleted, the old row isn't immediately gone from Postgres. It's labeled as a dead row. And a vacuum is this functionality built into Postgres to clean up that dead row. So lowering the scale factor makes it more aggressive. So a smaller percentage of dead rows will trigger a vacuum with a lower scale factor, and increasing the cost limit means the vacuum will do more work in a single run. There's a reference there to the write-ahead log. So increasing the max write-ahead log means there's fewer checkpoints in a transaction that Postgres will accumulate, and increasing it will lower the amount of checkpoints, and it's typical for a high write sort of load. So that worked well, but not enough. There's 2 points here, and these basically did the trick. So the first one is a sort of application level thing. With SendGrid, there's webhooks you can subscribe, you can listen to. You receive a webhook for every email event, such as it being delivered, being it opened, if it's spam, things like that. I think there's 8 or 9 different events or something. So for these particular emails, we stopped listening to the webhooks. So if you saw on the previous slide, there was frequent updates to the row. That was the webhooks. And it's also important to note that this table in the database had, I think, 6 indexes. I think there's a gin index, a gist index, bunch of B trees. I can't remember exactly, but there's a bunch of indexes that constantly were getting created. Well, when they get updated, they get recreated, and that was causing the update to be so long. And then the second one was bumping the machine size. So we went from 4 to 8 CPUs, a Graviton 2 processor to a Graviton 3 one. And after doing this, it was quite amazing. When we ran it, you could just see the email service just smashing these tasks out. It was crazy. So at this point, we're pretty happy. Like, oh great, this is running really well. It will be a breeze to get this all done. But there were more issues. Oh, actually, before we get to the next issue, so these are some interesting diagrams of when I guess we were smashing the CPU with the 4-core machine. So it hit 100%, and then as soon as we upgraded, it was just a breeze. And you can see on the image to the right, I thought that was really interesting, the relative load to the number of CPUs, virtual CPUs. So you can see just after that massive peak, it's just so easy. So that's quite cool. So some customers are receiving multiple emails, and that obviously sucks. I didn't test it with myself to see what Gmail does. Maybe they hide the emails. I don't know, but we told our PM, and we just had to accept it because there was nothing we could do. It's an issue because then people mark you as spam, and that can screw up your email legitimacy, and then people start receiving your emails, which is a whole nother problem. So it's not ideal. So as I said, we had a column on the table to make it idempotent and to track this, but obviously it didn't work. So in a quick solution, we thought of applying a lock using Redis. So what this looked like is basically this. So in our code, we use this cache add method. So this was from Django Redis, which uses the Redis library, I believe. The add does a get, and then I'm trying to remember exactly what the add does. But quite clearly, if it's we add this unique key. If it's there, it returns false, and then we won't run the xnotify send email. But if it's not there, returns true, then we do run it. You get your email, and we put a TTL there of 5 minutes. So looking at this in Elasticache on our Redis metrics, this worked really great. You can see so clearly that in every 20 minutes, the memory hits a point, and then it frees up due to the TTL, and then when the next batch runs, it goes up again. So that solved the problem, to be honest, and we were really happy. Oh, great, we can run the rest of these emails. And then there was a third issue. So our Redis memory for our celery backend blew up. So it hit 100%. We started getting 500 endpoints, and immediately I asked DevOps to increase the Redis size. So you can see here it hit 100, and then they increased it there and went down. So solutions, upsizing, and the big solution here was just ignoring the result. It did mean for things like Flower, you couldn't see it, but we had other observability ways to make sure that everything was running. We had dashboards. I think we even had a Datadog monitor set up for alerts. And you can see me here posting in our Tech Python channel. So this got quite interesting. So you can see here, I did some investigation into the Redis memory to see what keys were hogging all the memory. And you can see there's a bunch of these reply, I don't know if that's clear enough for everyone, but reply.celery.pid box. So a bit of a mystery. No one really knew what they were, but after some quick Googling, you can see a lot of people had no idea what the hell this was. And eventually, after some more digging, you get to like this GitHub issue, and you see people just manually deleting it. And here was some really nice code that just you ran this, using your Redis connection, and it checks for keys with that name, and if the idle time is greater than a week, it deletes it. So it's pretty safe to say after a week, it's just this orphaned bit of memory that just is taking up your Redis memory. So you can see here, I played around with this for a little bit, and then at some point after the 5th of January, I just did a huge one for some reason. Yeah, probably because it was after a week of me running a lot of these things, and it just significantly dropped it. So after that, yes, okay. So after that, everything was pretty sweet. We were confident, and we completed the rest of the batch, and yeah, we were satisfied with it. So what would we do differently? Read the docs. So ETA was the biggest culprit here, and it's a real testament to the complexities of Celery. It's a combination of Celery and using Redis. So you'll see here on the docs, there's this massive warning sign, and if using Redis as broker, the task will get redelivered when countdown exceeds visibility timeout. So what the hell does that mean? Countdown is when you tell Celery to execute a task at a particular time, and that's what ETA was doing. ETA, estimated time of arrival. We're telling it to run at some daytime in the future. Visibility timeout, this is a time window. When a worker gets a task from a broker, the task is invisible to other workers, and it's invisible to other workers for the duration of the visibility timeout. It's an int representing seconds. This prevents other workers from picking up this task. So the default visibility timeout in using Redis is 1 hour, and our countdown time was obviously greater than 1 hour because we were doing 20-minute batches. So after 3 batches, it was greater than an hour. So this issue was happening after the 3rd batch, and we were running up to over 100. So yeah, not ideal. So doing some Googling, there's a bunch of different solutions, and this was quite the rabbit hole, to be very honest. So you can set a large visibility timeout. So you got to set it on three lines in your code, which is a bit smelly. That's not ideal. Consider how if you've got a task and it crashes, it fails in an hour, but your visibility timeout is a year, it's going to take an hour till, well, the remaining time for your visibility timeout for another worker to pick up that task. So it's pretty bad setting this to a high number, because yeah, that could cause all sorts of complexities in debugging things. Why wasn't my task running after it failed? It's because it had to wait for the rest of the year to finish. So it's often recommended to use the task acts late. So when this is true, the visibility timeout becomes irrelevant from long-running tasks. So late act means the task messages will be acknowledged after the task has been executed, not right before, which is the default behavior. So consider you've got a long task, your visibility timeout's an hour. With this true, it won't be acknowledged, and yeah, that visibility timeout is irrelevant. The workers just continue to be working. No other workers can see that task because it hasn't been acknowledged. It's still, nothing can see it. Third point is using RabbitMQ. So RabbitMQ does have native support for TTL and delayed exchanges, which is specifically designed for scheduling messages compared to Redis, which Redis doesn't have any sort of native time build functionality. And then my last point is using Celery Redbeat. This is a separate process that just runs periodically to run something, and that uses cache to store Redis to store config data, like cron data. Yes, so I think this is my last slide. Yeah, this is my last slide. I think I flew through it. So yeah, read the docs. I would have used Celery, Redbeat, and tasks act late together. So Redbeat would have started my task. If the task went for a while past the default visibility timeout, it would have been fine. No other workers would have repeated my task, and the customer wouldn't have received 8 emails. I forgot to mention, sorry, so refactor implementation to use indexes rather than pass large data structure. So with the large keys that were in Redis, I saw online that, yeah, this is common when you pass a large data structure into the task. So yeah, just passing 2 ints would have been much better than a dictionary with 10,000 keys. And then the most important point, do this after the Christmas holidays. It's a terrible time to do it. And yeah, that would have solved a bit of stress we experienced. And yeah, that's about it. Do you guys have any questions? Yes?
Alex, how do we track the failure?
Yeah.
Like the task, let's say, send 1,000, if the crash after 5,000, what do we know? What the
Yeah.
Can you repeat the question for the recording?
Oh, yeah, sorry, I'll repeat the question. How do you track tasks that failed? Yeah, in the middle of processing the batch. Well, yeah, so the batch sent like 10,000 requests, and we were tracking the responses from Xnotify, from the email service. So we had that level of granularity where we could see like if it was a 200 or a 201 or I don't know, 500, or I don't think there's any rate limit on that endpoint, which yeah, thankfully there wasn't. Well, I mean, there probably should have been, but yeah, we would have seen it in our logs. I know with Django logs we have some like wrapper that does the log if the task fails, and we would have seen it from Sentry, I believe. But it didn't happen, thankfully. So
it may require manual checking.
yeah.
Collect some log data.
Yeah. I think we could have searched Datadog for some failed task. Fortunately, that didn't happen, but we did get some unexpected responses from Xnotify, and we're actually still in the process of rerunning some things. Yeah, no worries. Yeah.
I didn't understand why was the large data from the task arguments persisted in the cache? Is that like a default setting?
Those PID keys?
Yeah.
Yeah, so that was really that was quite odd, to be honest. Yeah, this stuff. So yeah, sorry, I didn't explain why. From reading online, these keys are used. It's like implementation details for the way Celery talks to Redis. For some yeah.
They don't have a timeout?
No, I don't think they have a timeout.
Because that's a big bootcamp for anyone using Celery with Redis. You're going to accumulate like those.
Yeah. So I can't see this on my machine. Oh, it's on yours. Yeah, I totally agree. I can't exactly recall, because you'd think, yeah, over time these would just accumulate and everyone would know. Yeah, well, no, I don't think it was a memory leak. It's this thing which is well documented on the internet, and yeah, I know when I raised it with DevOps, they even mentioned that they could see these keys didn't have there were many keys that didn't have a TTL set, and they were just there infinitely. which is pretty odd. But there's got to be some cleanup process by Celery. But yeah, I suspect in my case, because we were sending such large data structures, we just saw this huge increase, and maybe the Celery process didn't kick in time. I'm not too sure, but yeah, it was a bit painful. Hopefully that answers your question. Yeah. Yep.
Okay, why did you end up starting with the files? Why were you not querying
A database.
Yeah.
Yeah. So why did we start with files instead of querying the database? We've got a data warehouse that is BigQuery, and basically we ran a query with some certain condition to figure out what customers we wanted to email, and I had a list of customer IDs from that. I didn't have the email address. We have got compliance rules about exporting an email field out of our data warehouse to a local machine. So using these customer IDs, I could then query my table to get the email and first name, and yeah, that's why we start with the files. Compliance, yeah. Yeah, it wasn't pretty, but it was a quick solution to, yeah. Hopefully that answers the question. Yep.
Yeah, since you send a very large number of emails in a short time, have you got any notification from the email service providers that you send too much emails and your behavior looks like phishing or fraud, and how do you deal with that?
Yeah, so the question, considering we send so many emails, have we got any responses from the email provider, SendGrid, in case it's fraudulent? No, I don't work in the team that directly works with SendGrid. I'd be really interested to ask them that question. I don't believe so, but I don't know for sure. Yeah, it's a good question.
Those were dynamic emails, right? So it's not the same.
Dynamic emails.
Right, the content of the email was dynamic.
Yeah, we had. Actually, I think it was the same. Yeah. I said first name earlier. We didn't have first name in it. It was yeah. Yeah, we did do translations. Yeah. But as I said, if a customer received 8 and they said, because at the end of the day, we're an insurance company, and you book a holiday and you buy insurance, you often forget about the insurance, and you're going to see 8 emails from Xcover. You're probably going to be like, who the hell are these guys? And probably mark the email as spam. So potentially that got back to SendGrid, and that might just ruin our I forget the term, but our reputation. Yeah.
How do you think about the synchronized? I see you're currently sending email actually the synchronized way. How do you think about using asynchronous?
Question: did we consider using async requests?
Yeah, I'm pretty sure if you use async, you can finish in several hours.
Yeah, I would question whether we're smashing the email service too much.
That's a problem.
Yeah. In the service I work in, that customer service, we don't have any asynchronous request libraries installed. We could easily add HTTPX, or something along those lines. Yeah, I mean that could have been a good idea, but it was probably outside of the scope for the quick solution we had to come up with. Yeah, but yeah, as I said, I'd imagine that would cause more strain and stress for other systems. Yeah.
Did you consider talking directly to the SendGrid API because you had your backend into it?
Yeah, the question: did we consider talking directly to SendGrid? No, we didn't. We couldn't actually, because this email service has a lot of business logic to handle different. We've basically got a CMS as well. There's another microservice, and we specify an email template, and this email service will fetch that from the server, CMS service with the specified language. So this service encapsulates, a CMS and it handles translations. So we wouldn't have been able to do that talking directly to the without a lot of manual stuff on our side. Yeah.
And do you know how many emails you sent in the end? Like 100 million or?
Well, we got on top of the duplicate number relatively quickly. That was within the first like 500K test batch. Thankfully, so we're 100% certain the Redis lock did work because we were checking that quite a lot. Yeah.
So 15.5 million.
Yeah. Yeah, Rui?
Just on that note, did you ever figure out why the item potency failed in that initial batch?
So the question, why did the item potency fail? Yes, we did. So where's the code? So yeah, you can see here. It's a bit. I'll just make that a bit larger. Sorry. Yeah. So we write to the table after we send all the emails. So because this task was taking so long, because of the whole ETA thing, and multiple workers were picking up the same task, this code would all run. Each worker would run all this code, and then it's only at the end we write to the database to say that these customers were completed. So it's kind of like premature, not optimization, but the reason we did this was because we didn't want to update a row for every customer iteration, but that would have been simpler. Yeah. So at the time, I thought this was a good idea to just have one update SQL statement, but instead it actually hurt us quite a lot. Yeah.
So what's the extent on that trial?
Oh, it's no. This was what this website was doing. The line's kind of wrapping around. Yeah. It's yeah.
Oh, no.
Yeah. It's I don't know why it did that. Yeah.
So final question.
Yep.
So you decided to do that to be faster, to optimize.
Yeah.
Are you happy with that decision?
What
the batching, or the doing it at the end, rather than actually using the item potency for what it was meant to be and writing as you go?
Well, I wasn't happy with these customers receiving the same email. But I think the thing here was we weren't due diligent enough with using the ETA command and reading the celery docs, which is so obvious. That's why it's so painful. I was writing this talk and I was like, oh, I'm such an idiot. This talk's going to be embarrassing. But it is a good learning experience. Yeah.
Somebody reviewed it.
Yeah. My direct reports. Yeah. Iris isn't listening. Yeah. Cool. Yeah. Well, thanks, guys.
Next up, we have Iqbal talking about property-based. Oh, we're swapping. Okay.
Yeah, same computer.
But the talk title stayed the same this time.
Yeah, pretty much. Can you guys see that?
Maybe
Nice. It's all yours.
cheers, man. Thank you. Thank you. Hello, everyone. My name is Erfan Paksima, and today I'm excited to share with you how we utilize Django at Mylot.ai to drive real-time AI solution that streamline planning, inquiries, and approvals. I'll walk you through our technical architecture, key Django features we rely on, and also the challenges we overcome. So first of all, why Django? So obviously we chose Django for its rapid development capabilities and its robust architecture. Basically, it handles, sorry, that's the note. Yeah, integrates seamlessly with our tech stack, including Postgres, React, Redis, AWS, ECS, and especially its real-time IO features through Django channels, which makes it basically ideal for building AI-driven workflows that requires instant feedback and data processing. So basically, Django acts as the backbone in our architecture. It handles everything from data management, user authentication, to serving API endpoints to our React-based front-end application. And also, it's the core that orchestrates our AI workflows. So to provide users with a easy and seamless and secure authentication experience, we've also integrated Microsoft Single Sign-On, and using which user can use their Microsoft credentials to log into the system. And we basically handle this through a library called Django Auto. And this approach basically allows us to easily basically integrate additional SSO providers using the panel that it basically adds to Django admin. So we also use Django to manage and integrate geospatial data. And we use PostGIS and GDAL to achieve this. And basically, this allows us to display satellite image of the property and its boundary, and basically various map overlays directly within the application. And basically, these visual insights and geometric data, it's quite crucial for our experts, and because it can kind of facilitate and also help the agents analyze the planning case more easily. So we've optimized performance through various techniques. So for example, strategic caching, asynchronous task management, and also database indexing and database optimization, and database query optimization by leveraging AWS ECS, Celery, Django RM, and etc. So we use Celery basically to handle both parallel and asynchronous task management, and basically it functions as a distributed task queue, allowing multiple tasks to run concurrently and offloading heavy running tasks and processes from the main workflow. And this approach, this asynchronous processing ensures that our core operations remain responsive and non-blocking all the time, and significantly improving both performance and scalability. So use Django channels basically to deliver instantaneous feedback without relying on polling methods. And rather than using as a standard chat interface as we initially did, we transitioned to a wizard-based approach. Now, basically, the interaction is guided by dynamically generated forms and questions, which are tailored to the user context. And these questions can come in different forms. For example, you might get a drop down, or you might get a text field. And this evolution has allowed us to provide a more structured and intuitive user experience while still using the power of real-time communication. So at the core of our system is our custom built agentic AI system built within Django. Basically, this engine orchestrates a chain of expert approach by calling a network of agents in parallel and dynamically generating follow-up questions and eventually final reports. It also handles errors during execution by employing various techniques. For example, an exponential backup when hitting rate limits on the calls to our providers, LLM providers. To do a more deep dive into the system, the agentic system. So as I said, we leverage a chain of expert approach that employs specialized experts, each focusing on a specific domain. And for instance, analysis of the impact of an overlay on the planning case. So to ensure that the expert receives precisely the input that it requires, we've developed a dedicated context retrieval system, which basically extracts targeted portions of the legislation or application information. Basic of a legislation data ingestion pipeline imports and annotates data, annotates legislative documents, which then will be used by the context retrieval system to be prepared and sent to the relevant expert. And eventually, to basically handle this complexity, a dedicated processor orchestrates the entire chain. It dynamically prepares and passes the required inputs, whether derived from our context system or generated by previous experts to each agent. And the graph here shows basically each of these boxes is displaying an expert, and the lines are showing the relationship and the dependencies between the experts. To guarantee that our experts perform as expected, we've implemented a testing system as well. And this system allows us to reprocess both mock and historical applications using new or updated basically agents or experts. And basically through manual and also automated validation, we ensure that each agent's output meets our predefined standard, catching basically any anomalies early in the process. By conducting these pre-published tests, we can minimize the risk of disruptions when rolling out changes live. So obviously for our internal data management, we've customized Django admin. But other than that, we've also integrated Django HDMX, basically to allow us to manage and monitor our AI agents execution, and also our test cases and a number of other internal processes. This integration basically has allowed us to iterate and develop more rapidly. And to ensure our system remains robust all the time, we've integrated Django with both Sentry and CloudWatch. Sentry provides real-time error tracking and alerting, enabling us to quickly detect and resolve issues. Meanwhile, CloudWatch monitors our system logs, and basically this entire setup help us proactively identify potential problems and facilitate faster debugging and continuous system optimization. So, like any other complex system, we've faced our share of challenges as well. Managing obviously real-time data and ensuring reliability during high concurrency has required continuous performance tuning, and also balancing automation with system robustness has also been quite a challenge and has been a learning experience. But obviously, by using Django's extensive feature sets and following best practices, we've managed to successfully navigate some major parts of these challenges, and we continue to improve our system. And for the future enhancements, we're obviously looking forward. We plan to further enhance our Django implementation by exploring additional asynchronous processing capabilities and fine-tuning our API endpoints, even for better performance. We're also working on deeper integration with our AI workflows and geospatial data. And our goal is to continue scaling and optimizing our Django infrastructure to meet the future demands. And thank you so much for your attention. Any questions? Yes.
Are you using an agentic? What do you use to manage the agents, the AI agents?
So we've built basically our own system. Oh yeah. So we have sorry, forgot the question.
Question is, what framework do you use to organize the agents?
Oh yeah, so what framework we use to organize the agents. So we built our own kind of custom agentic system. We tried a couple of already built agentic systems like LangChain, but they were not quite fit for our use case. So we had to kind of come up with a new design.
You mentioned the LLM provider. You mean the world's provider or the API? It's related to the
Sorry, can you?
You have some LLM provider.
Yes, we use LLM providers. We don't have.
What do they provide? Models?
So we have not built our own LLM models. We use LLM providers like Anthropic, OpenAI. We just integrated Google, and yeah. And for each of the experts, we use a separate model, a dedicated model. It doesn't mean that like all these experts are using OpenAI. Some of them might be using Anthropic. Some of them might be using 4o, OpenAI 4o, or some of them might use the new O3. So for basically, initially when we started a project, our system worked like we had this chat interface where user would just start asking questions, and then immediately after receiving each message, we started a new process. We spin up a new Zero task, and this task would go and look at the chain of experts and then start basically calling them. And then, but then we basically changed the approach to be a wizard-based, but we basically never switch it back to API-based approach. So basically, whenever an expert finishes a job, it just notifies front end there's a change. Maybe send a new question to front end, and then yeah, front end just displays that.
I have a question. So that really cool graph that you showed, where every circle is like a different agent, and there were lines between them. So how did you like build that in the graph, or did somebody context on the relation to this agent?
Yes.
And then basically this agent will then somehow come to the after getting this piece.
So the question is that how the experts are created and how their relationships are defined.
Yes.
Yeah. So basically, we have a couple of prompt engineers working at the company. They're just working on enhancing these experts. So what we have is that we have this expert, which is basically just a Django model, and then an expert is actually just a prompt, and then it has all the configuration it requires as a field. So for example, it has inputs and it has outputs. So the inputs can be, for example, you can specify the output of another expert as the input. So this way you are defining a dependency between the experts. And using these basically information, we are able to basically display that graph.
You mentioned on one point a trade-off between using AI and reliability. Can you expand on that and how you observed reliability issues and how you...
So obviously there's hallucination and all the things that come with LLMs, but the thing is that we build our testing systems. So for example, when prompt engineers want to change an expert, update an expert, before promoting it to production, so we have this system, they can just basically say, okay, I have this number of conversations or application, take this conversation and then pass it as a context and use its information, but now use the updated version of the expert and try to run the analysis and see the final report, and then you can compare it, whether it's working the way you want. It's a manual way. But we've also added a new feature where another LLM actually looks at the results of the two, say, oh, okay, there's an issue here, or everything is fine.
So you mentioned you had panel of experts.
Yes, panel of experts.
Would you, how would you decide which expert you're going to, or is it like a panel?
So yeah, that's a, yeah. So how do we know which expert to run? So that's the question. So as I said, the configuration of the experts are defined within the expert model. So we have this central, let's say, function. We call it this function and say that, okay, give me the list of experts that I'm supposed to run right now, and then it gives us, let's say, 4 experts. We run them, and then it's like a cellular task. And then once the process is finished, at the end of that function, it calls again that central function that I was talking about. And again, it kind of schedules the next set of experts to be executed.
There's no experts are all the same, they're not specializing.
Yes, they are. Exactly. So it basically, the question was that the experts are basically not same. They're definitely different. So for example, one expert is designed to analyze LSIO or just some parts of the planning legislation. But another one might look at your, for example, to see if you're actually going to remove a tree, because it's going to change your planning kind of result. Yeah. They are specialized in a specific domain. Other question?
Are you able to feed it images?
Yes, yeah. We do have just one currently, one vision expert, where we just pass the satellite image of the property and its boundary as well. And it kind of can see if there are actually trees in your property. It asks you, hey, I'm seeing some trees here. Are you going to remove them or not? If so, you have to explain more. Any other questions? Cool, thank you.
Thank you very much. Last but definitely not least, we have Iqbal. Property-based testing.
Yes, sir.
Excellent.
Awesome.
Hey, I'm doing so good to see you too. Oh man, I was terrible. It is quite interesting. What if?
Oh,
Sorry. Awesome. Testing 1, 2, 3. Can anyone? Right, actually, whoops. Okay. Can everyone hear me fine? Everyone in the back? Awesome. So yeah, like I just wanted to talk about testing in general, right? And testing's pretty boring, and it's like in computer science, everything starts off with a function, and a function is something that takes some inputs and it maps them to outputs, right? So you might have like fx is equal to x square, and testing that's pretty easy. So you can have like the brain of a really small monkey, right? And you can say that, okay, fine, basically, you know, there's a positive number, I square that, it's going to be a positive number, 0 square will be 0, negative number will also be a positive number. You'll take basically examples from each of these classes, and you'll write a regression suite around it, and these classes are called equivalence classes, right? Now, to test something like a gradient of a function, you need a slightly bigger brain. This is the brain of a gorilla, right? It's got more neurons, and you know, it's like you'd have like more equivalence classes, like, you know, positive slope, but that's not one equivalence class, because, you know, it's like you might have a positive slope inside the first quadrant, second, third, fourth. So basically, this is actually 4 classes. So, you know, this is probably like something like 24 equivalence classes. And, you know, it's like you're writing a test suite with basically 24 test cases, and, you know, it's like you're getting tired really fast. And now let's come up to something even more excited, where, you know, you need a human-sized brain. Like, you know, you might have something that can basically do the tax return for your company. Now that's going to be, you know, it's like it will probably take you 6 months to write something where you capture all of the ATO's rules, right? How do you begin to basically write equivalence classes for, you know, something like a hash function, right, where you can pass it any data, and it needs to basically, you know, take out examples. You can feed it millions of examples. Are those examples representative enough? How do you basically draw out equivalence classes, which are geometrical lines on a hypercube, which is basically, you know, like, and like a lot of these problems are like, you know, 12, 13, 14 dimensional things, right? You just can't. And random numbers is another one, but random numbers is easier. But there has to be a better way. Can anyone guess whose brain that is? Yeah, I think I think that it's the brain of a dolphin or something. But yeah, maybe they're smarter than us. All right. So another way to look at the same problem is that, you know, rather than kind of like coming up with a set of test cases, we think about basically properties, right? Like, remember when we used to learn mathematics, we used to like have this boring stuff like, oh my God, like, you know, commutative property, a plus b is equal to b plus a, associative, distributive. And like, these are the properties that define what an integer is, right? And the cool thing is this, that basically if you wanted to write some tests around this, so there's this really cool thing. It comes out from the Haskell world. There was this guy basically who wrote a program called QuickCheck, right? And it became very famous, and from there it entered like all other languages, right? So you can write a test saying test integers are commutative, and basically you can have a strategy, say strategy.integers, strategy.integers, and you run this test, and it will feed it like millions and millions of examples, right? It'll probably time out after 5 seconds after running 10 million samples. And basically, if for anything, basically this test fails, it will just basically store it inside a local database, and then, you know, it'll be like adding it to a regression suite itself. So, you know, it's like, because computing is so expensive, and the age of generative computing shows this, that, you know, we're literally like, you know, throwing a lot of crap at computers, and we're just making them work. So this is another way to make computers work. And, you know, it's like we're just hoping that it captures all of the, I mean, a good enough representation of the equivalence classes, because computers are that fast, right? So you can easily write like test cases for testing integers. And like, this is probably really good if you're writing NumPy, and NumPy does use generative testing. So yeah, one real world use case covered. All right, now let's think about properties for random numbers, right? Can anybody recognize that thing up in the top left corner?
It's a computer from the movie.
Hitchhiker's Guide to the Galaxy. Yeah, exactly, right? Like, so testing is so boring that basically it even makes robots sad. And, you know, it's like the moment we hit AGI, robots will not want to work anymore, which is why I like traditional computers a lot. And this is another interesting device. This is a GM tube, right? It kind of like detects radioactive emissions, and like that's one of the more random phenomenon available inside the universe, right? And then you've got Excel over here, right? When you generate a random number through Excel, is it actually random? Yeah. It's pseudo-random, exactly, right? And now this is really funny, because this is like a bunch of random numbers. This is basically what, so for example, if I take random numbers and I make pairs out of them and I plot them on an XY graph, this is what noise looks like. And now if I do the same thing with Microsoft Excel, I can see, can you guys see patterns in here? I can see waves, yeah. And that's the thing, right? And people use Excel to run Monte Carlo simulations and all of that other stuff. Basically, it's generating crap. And it's like, yeah, the MBAs are really good with it, and they're fine with it. So because they can't run write property tests, I guess, right? So the thing is that basically, like, what kind of properties would you guys design if you guys wanted to test random numbers? Any ideas? Okay, so one property is this, that okay, fine, basically, like maybe I put my hand in a bag of random numbers, pull them out, and I look at basically how many repetitions I'm getting. I try to basically encode that into some sort of property, right? There's another thing that basically maybe, like, if I take a random number generation that's spitting out stuff between 0 and 100, and I take the median needs to be around 50. Another one is this, that basically, like, I try to basically take little squares in it and see that each one of those squares has got a good statistical representation. Like, I don't want a lot of stuff in here, right? So for example, like, Excel would have been easily caught out by this test, where it's like it would say that some of these 2x2 squares are much more dense, right? And then it's like I wanted to kind of like test property testing on random numbers, because it's like at work you don't have work all of the time, and you need to create work for yourself. So I kind of like generated a random number generator which just counts up 1 2 3 4 5 6 7, and when it hits 10, then it floors, and then it goes up again and again. So it's a seesaw. This is like the most crap random number generator you could probably have. Then I took one random generator that was used in the 1950s in the mainframe era. It's like probably DARPA used it to like do some nuclear research or something. And then you've got PRNG, which is basically the random number generator that was used. That was used commercially, I think C and C++ until 1998. And then you've got like the Mersenne and Twister, which is basically a random number generator that Python ships with, right? And I was thinking that, it's like, okay, like maybe I'll waste today at work in order to see if I can come up with enough properties to kind of like tell, state of the art 1998 versus everybody else. And funnily enough, it was a lot easier because a lot of this stuff is crap. And let's just plot this like these 2x2s, just kind of like so that we get this little thing, right? So the thing is that, it's like to the naked eye, naive is crap, right? Because it just goes tick, 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 down, tick, 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 that's it. It's a zigzag. Middle square is basically the 1950s state of the art technology. And like, again, you can see a pattern in here. And now in Mersenne and Randu, at least like you can't tell with the naked eye what's going on in here, right? But then basically I kind of like came up with, the same test cases that we kind of like discussed, right? Oopsie. All right. Test randomness, right? So I just set up some tests. I just wrote one simple test for repetition, where it's like I'm like, okay, fine, I'm just grabbing a couple of them, I'm seeing how many of them are repeating, and like at a certain tolerance I fail the test. The second one is test median, and the third one is test 1D uniformity, right? Which is like not even a 2D. I'm just putting them in a line, slicing up segments out of that line, and just seeing that basically are the random numbers it's generating like uniform. And I thought that I'd need to go much further, but basically when I ran this thing, right? So this is basically the output from the run, right? So middle square failed 2 tests, 1D uniformity and repetition. The naive thing that I made failed them both, and Randu failed 3 tests, and middle square failed a few tests, and like everything out here failed a couple of tests. So it's like, I mean, even this amount of property testing is enough to kind of like, draw a line at 1998 and say that, this is good enough to test the state of the art. Now, how can we make Mersenne and Twister fail? And the thing is that like, it's kind of like a very hyperdimensional problem, right? So the thing is that like, if you were to draw a matrix with 55 or 56 dimensions, and you ran a test 56D, basically a test where you're sampling hypercubes of 56 dimensions, this test would fail on that stuff. Now, of course, we don't have computers powerful enough to do it. So basically, that's why I guess it's state of the art. But it's like that. These are just some classes, so it's a way to think about this, right? And easily, like you could kind of like come up with properties of uh, a shopping cart API, right? Okay, fine. Basically, I'm hammering an API with basically this generative test strategy, and it's like my shopping cart should never be negative, right? Everything that I've put in there should total up to a specific number, and it's like it sounds very easy, but basically when percentages, GST, and everything gets involved, like maybe 70-80% of programmers don't know how to use decimals properly. So basically, I'm pretty sure that this kind of testing can be very useful. You guys are the ones who know how to use decimal properly. All right. Okay, so cool. And like it's like this kind of code that I wrote to generate those plots and stuff. So I was playing with ChatGPT as well. It can generate a lot of this stuff for you. You can just say generate 500 random numbers, and it can kind of like do this kind of stuff for you. So it's like it's pretty handy. It's like I must say, and it also knew how to generate basically the randy ones. So you can see some sort of patterns in here as well. So I guess that I'll use ChatGPT more. Awesome. I digress. Back to random numbers. Yay. All right. Now the thing is that basically, like we've talked about properties when it comes to basically, random numbers. Now let's just talk a little bit about hypothesis, right? Now the thing is that basically it's really cool because it's this library that can basically test things, remember what it did, and basically give me a repro. So over here, I'll go to a very silly implementation of what is it basically test database, right? So there's a strategy in testing saying whether you're testing parallel things, right? So for example, let's say that if I want to write Redis or like a Redis driver or a database driver, I might have one in memory basically mock or fake, right? And basically I'm executing the same order of operations there and the same order of operations in my database. And then I need to kind of like, compare at the end that both of them agree. One collect implementation with the new implementation, right? I think that like Simon and I worked on a lot of like Salesforce syncing stuff back in the day. And like this could have been one way how to test that kind of stuff. And the thing is that basically over here, I got an add key function, an add value, a save, and a delete. And I've introduced some errors, right? So for example, if the length of basically the value that I'm inserting is equal to 2, basically, I'm not going to delete stuff from the database, right? So I can insert an error just to kind of like demonstrate the concept. And like at any time, basically, I can take everything from the database, fetch it, cast it to a set, compare it with basically my both implementations. And if I run this guy, right, so it ran in here for a while, it chugged along, and it gave me an example which is a falsifying example. It said that, hey, basically, now if I just paste this into a script that's basically a falsifying example, I added the key with basically an empty string, and then I added another key with this hex value inside it, a key value, and then basically I saved and I deleted this thing and I checked for values agreeing, and basically the values did not agree. This is your repro. It's being stored inside a database. And the next time I run this test suite, it'll start with these falsifying examples first. So it's a way to kind of like, I guess, empower your engineers where you can be much more smarter with test cases. And like machines can chug along, and it's like you can kind of like let them run these tests inside the background. So that's kind of like just kind of like showcasing some of the cool things that hypothesis could do. You could easily do this for a Rubik's Cube solver, and like it could kind of like show you a lot of cool things, or maybe basically matrix operations and stuff like that. Similarly, basically, like I had something similar for matrices, right? And I tried to use the same properties from integers on them, right? So for example, if I've got two matrix operations clockwise and counterclockwise, I came up with basically this thing saying that, it's like if I rotate and undo it, basically it should agree, right? If I want to basically rotate anything 4 times, it should agree with the original one. And it's like the shape should always be 2 by 2. And like I'm just specifying basically the strategies for the arrays, and like the decorators are pretty strong. It can say that, okay, fine, generate integer 16 array and reshape it to 2 by 2, right? So basically it's actually throwing a matrix inside it. It will execute these strategies, and of course, I mean, everything will be fine unless we introduce a bug. So over here, when I ran it, basically, so there's a slight bug inside this implementation. When I ran it, it kind of like gave me a falsifying example saying that basically, it's like your matrix library is basically failing when you use this example. And it's like the one of the tests is failing. I'm not, yeah, the commutative quad fails on this stuff. So basically, again, like it's kind of like it's doing the job of a manual tester where the tester is working at one level higher. Is everyone with me so far? Yay, awesome. All right. And then basically it's like, well, I don't think I have much more content, but let me check. And then like for really lazy people, who just don't want to do any work, right? I don't even want to generate test cases. Oh my God, right? So there's this kind of like thing called schema thesis that can kind of like, just look at the shape of an open API spec and throw trash at it and try to get, the server to generate an incorrect status code, get the server to crash. And it's like I'm like, okay, fine. Basically, it's like, how do I validate schema thesis? And by the way, basically, a lot of big companies like Netflix use schema thesis already, so it's a pretty popular tool. And I'm like, okay, fine. Like I'm just going to look at the API for something in the open source world, right? So where is this guy? All right, so I got a wallet service. I don't really know what this thing does, but it's like it's got an open API spec, right? It looks like this. I can list transactions. I can add a transaction, which is basically a wallet ID, transaction type, Boolean, and basically some amount. And basically, I can kind of like look at how many transactions and how much money is in any wallet, right? And I really don't want to waste time in here. I just want to see if this project is even worth looking at. I ran basically a schema test on this thing. I just gave it the link, strun, and basically the link. It chugged along, and basically it made like a lot of failures. So basically, it's like, for example, and it's kind of like written the curl, right? So for example, if you hit this curl command, the server will crash and it'll spit this stuff out. And similarly, like it's like it's come up with a bunch of test cases which crash the server or make it basically respond with undocumented or incorrect codes. So yeah, like at least, and then like Sec Hypothesis has a lot of first-class support for Django, so you can use Django Hypothesis. And I don't want to bore you guys with basically the API details, but you can have like Hypothesis basically injecting data into Django's test runner natively as well. And yeah, that's about it. I'm not as smart as you guys, so it's like I guess this is it. Small, simple, and sweet. Any questions? Sure.
The testing randomness is a technique called cross-correlation, which you feed a signal into it, and then it will tell you, like it's using electrical engineering to pull out the noise. So noise should be random, entirely random. And so if you run a cross-correlation function on it, it will tell you. So if you that the one, the truncated one, where you're seeing the patterns, that they would stand out as big themes in a cross-correlation.
Cool. And how does that work? You correlating
matrix math. Just
all right.
A bunch of stuff, and you run it against each other.
Okay. Okay, so you're shifting it into the Fourier domain and basically
something like that. Maybe, but yeah, that's a way to check if something is random. To run a cross correlation function. If it is random, you'll get
cool. Yeah. Good to know. Sweet. Did you have a question?
I'm curious in terms of what's in your experience, what is a good or like a classy expert, because that's what the versus having where's the sweet spot?
I think it's like if the equivalence domains are easy enough to imagine, then of course you can go with like regular regression manual testing and stuff like that. But basically, if you've got something that's very complicated where you don't have a lot of confidence in your ability to be able to basically it's like partition the test domain, then basically it's much better to throw a generative thing at it, because computers can just throw a lot of examples and catch something that you wouldn't have otherwise. So it's like, for example, exactly like if I wanted to build like a tax calculator or an LBR calculator, I would definitely start off with basically hypothesis testing as opposed to basically writing test cases, because it would probably take me 3 months to get them right.
One thing I like to think tools is in terms of assumption minimization. Like I think that's a broad category, and I see this tool as a member of that category. And for example, when I say assumption magnification, when you have, let's say, a function that takes a number, if you test with 0, you test with 1, you test with 5, and you call it a day, you're making a whole lot of assumptions about how representative those numbers are. And for example, one way that I apply this to other real world scenarios is, for example, making sure that my model factories as random as possible. So you're not making assumptions on the things that remain static on your factories when you're running normal unit tests. You want to set the things that you say explicit in your test that will remain in a certain way. You want those to be static, but everything else you want to randomize as far as possible.
Yeah, you're absolutely right. And it's like, I think a lot of CI/CD pipelines, like I used to always introduce randomness inside tests, and everybody else used to say that you're writing flaky tests, and I'm like, no, it's got something that you guys wouldn't have got otherwise. It's by design, right?
It's all the test is wrong.
Yeah, exactly. So
for example, let's say your user factory assumes that a user is active, for example. Okay, no, let's make that the user may be active, maybe not. If you want the user to be active for that test, then you have to put it explicitly on the test case that you want the user to be active. Otherwise, you want that test suite to run, and eventually run a case where that user is not active, and then you correct your assumption or you correct the test.
100%. And I think this is also used inside the big tech companies, because they've got big cloud systems with so many dependencies that there's no way that they can write a test that encapsulates their entire architecture. So it's like at Amazon, they use this technique that basically Leslie Lamport had made called TLA plus. So you write like a bunch of like loose rules, and then basically you just simulate against that, and you hope that it catches a bug someday. And that's how they test these bigger systems. So you're absolutely right that our it's like software is so complicated that you need to go probabilistic, I guess. Cool.
The developer of Hypothesis himself actually used it against core Python and found a bunch of problems that were then corrected in core Python as a result. Exactly, because when you're sitting there testing, you think of some scenarios, but this thinks of all the things that you can plan for.
Yeah, and like this tool that I showed, the ST, basically, I think that they ran it against like basically the most popular web repositories, and it picked something up in like 80 or 90% of them. So yeah, like crashing servers is equal to like one day you'll get hacked, right? So yeah, cool, awesome.
Did you try running schematics against any AMOS?
No, I did not. Because then I have to fix those services. I like doing it on other people's stuff, not my own. Cool. Awesome. Well, back to you, sir. Thank you.
We've sort of a bit of time in our hands. Feel free to network. We do need to vacate by 8 o'clock. By tradition, we'll just carry on afterwards to a fire if there's enough interest. However, if the floor is open, if anybody has got anything they want to talk about, any problems they want to bring.
Sweet, awesome.